Is it on?
It's on now.
Hello, Brandon and Elena. We are on our Thursday edition. It's raining outside and
Beer.
everyone wants to go out and I said no. Show them the rain. I don't know if you can see it from there.
I can take her to it.
I can take her to it.
Wait, show her me for a second. Okay. I love you. The rain looks really cool inside.
Gosh, you better talking to Brandon too.
Oh yeah. Hi Brandon.
Brandon, you say Brandon will never watch him. You can't really see it.
Yeah, Elena Hall.
There's my car.
License plate number.
All right, come back. Come back.
Allie too.
All right. Here we go
I'm
again.
gonna get like motion sickness from it.
They don't have to see me, they can hear me. But if they can, that's fine. All right. We learned about experiments yesterday, on what they are and the language we use about them. And today we're going to see what makes a good experiment. Tomorrow we see what makes an experiment. All right. So let's stay on the good side. There's really only 3 principles I want to talk about for making, designing a good experiment. So let me give you your paper for today. Day 5. Allie showed them day 5.
Are we gonna work on this today and tomorrow or just today?
Probably just today. It doesn't look like we have much to cover. So, all right, 3 principles of experimental design that you want. You want to find these 3 principles. So, experimental design, when you design your experiment, look for these 3 things.
It's going crazy. It blurs in and then it blurs
We
back
want
out.
experiment design to be very healthy. So the first thing we only want the experimental treatments to differ between the groups. So I don't know if don't write that down until I get it up and I tweak it a little bit. I'll give you a moment to absorb what I'm trying to say and help me reword it. I think that's going to work. All right, an experiment's going to have at least 2 groups. One will have the variables changed and one won't. So one will have, only the experimental treatment differs between the groups. If there's more than that, then we can't make any conclusions. Sort of like the chocolate. If we had all these ladies who had normally eaten chocolate and those who normally didn't eat chocolate, they were lurking variables. In a good experiment, only the experimental treatment differs between the groups. So, we're going to read about 3 different experiments and see how we can see if that's true in each one so you'll understand better. So, other variables that are different between the group will muddy the waters and you won't be able to make any conclusions. So, let's use random assignment to the groups. So when you have 2 groups and one's going to have the variable administered to it and the one isn't, you're going to use random methods to assign the treatment. In your random design, there's 2 steps that have to be random. First of all, you have to use random choice of the people who are going to be in the experiment at all. Then you're going to choose between the people you've chosen a random group to choose who has the treatment, the changed thing, or who doesn't. So, random assignment. And lastly, there's really only three, is you want enough experimental units. So if you do an experiment on these 4 people in this classroom, that's probably not enough to make any solid conclusions. So we call that replication. Hey, how you feeling?
Lena.
Goodbye. You showed up.
Well,
No, Brandon's still here.
Brandon doesn't watch them. She said Brandon never watched them. She said last time he wasn't here, she's like, I want to make this and watch it.
The word enough is a little vague, and it all depends on how many, what the experiment is, on how many is enough. So you want as many as possible. All right, these are the 3 steps to an experimental design that is healthy. Here we are, we went over the homework, and now we're doing, we just started our notes on what is a good experiment. So only the experimental treatment differs between the groups. We don't have a lot of other variables that differ between our groups. We're going to use random assignment to select our people and to select who gets the treatment. And we're going to use enough experimental units so we can make good conclusions. They're called replication. Let's read some experiments. And how long do you think we've gone? 5 minutes?
Yeah.
All right. So go another 5 and turn it off and we'll start again. All right, would you open in your book now? We're just going to read to one another for a few minutes. We're going to read an experiment and we're going to notice these 3 things in each one. Okay, let's look on page 241. 241. All right, this is a physician's health study. It's kind of funny, the physicians are the ones in the study. So,
Pills.
all right, pills it is. All right, Caleb, start reading in the green at the bottom of 241.
Does regularly taking aspirin help protect people against heart attacks? The Physician's Health Study was a medical experiment that helped answer this question. In fact, the Physician's Health Study looked at the effects of 2 drugs, aspirin and beta-carotene.
Beta-carotene.
Researchers wondered whether beta-carotene would help prevent some forms of cancer. The subjects in the experiment were 21,996 male physicians. There were 2 explanatory factors, each having 2 levels of aspirin, yes or no, and beta-carotene. Combinations of the levels of these factors from the 4 treatments shown in figure 4.6. 1/4 of the subjects were assigned at random to each of these
All
treatments.
right, just pause there. Look at the little chart there below in yellow where it has all of the factors combined.
Oh, it's
So you could be in a group that got no beta-carotene and no aspirin, or you could get one of each, or you could get both. Do you see?
Placebo.
Right. All right. And a placebo means that you get a pill that just looks like the aspirin or the beta-carotene pill, and you don't know whether you're getting it or not.
people know.
All right.
people know
So,
about placebos for this
Ali,
to
you
work
pick up
properly.
reading where he stops on odd-numbered days.
I kind of want to make.
It's Allie this time?
Yep, it is Ali.
Okay.
You are a placebo.
On odd number days, the
Kidding.
subjects took
I didn't
either
know
a
that.
tablet that contained aspirin or a dummy pill that looked and tasted like the aspirin, but had no active ingredient.
A placebo. We don't need to take a note, do we? Do we know what a placebo is? Are we aware?
Yeah.
Placebo is a pill that's not really a pill. All right, go ahead.
Okay. On even number days, they took either a capsule containing beta-carotene or a placebo. There were several response variables. The study looked for heart attacks, several kinds of cancer, and other medical outcomes. After several years, 239 of the placebo group, but only 139 of the aspirin group had suffered heart attacks.
Wow.
This difference is large enough to give good evidence that taking aspirin does reduce heart attacks. It did not appear, however, that beta carotene had any effect on preventing cancer.
All right, so they kept notes on who was taking it and who wasn't, and they looked over many years and over the length of this study to see how the heart attack rates were. So, does this experiment that we read do a good job on number one? Only the experimental treatment differs between the groups. Did it do a good job on that? In what way did they do a good job, do you think, Julia? Only the experimental treatment, which was aspirin and beta carotene, were different between the groups. Because what did they keep the same, which was really wise? Because there could be all kinds of variables. Did you notice how when they first set it up, who took the study, Julia? Well, we'll get to random in the next question. But who actually was chosen to take the study? Pardon? Researchers? Oh, 5 minutes?
No,
Physician.
that was the
Oh,
thing.
say, no way, you're going to sneak out again.